So these are the things I want to talk about this morning. I'm going to start by spending some time talking about ice melting capacity measurements. I want to talk about the limitations of the test. I want to talk about how we interpret the data. How do we make sense of it? And finally, I'm going to talk about ways that we can improve the accuracy and precision of the test method. I'm going to spend some time talking about how we might measure deicer longevity. How is a deicer affected when it's put on the road as it is exposed to continual freezing precipitation? What happens to it, and how long might it remain effective? I want to talk about the important distinction between ice melting capacity and ice melting rate. And finally, I'm going to talk about the effect of pre-wetting on the ice melting rate of salt at very cold temperatures. So with that, let's go ahead and jump into it. So let's start by talking about ice melting. Now, why am I going to inflict a discussion of ice melt measurements on you this morning? Why do we care about the nitty-gritty of measuring ice melting? It's important because ice melting is probably the single most basic performance measurement that we have for a deicer. There's lots of other ways that deicer functions in the field that we want to understand. Ultimately, we probably want to be able to measure and understand how well the chemical breaks the bond between the snow and the pavement, or prevents the bond between the snow and the pavement. How well does the chemical inhibit compaction of snow to make it easier for the plows to remove? These are all things that we probably ultimately want to understand, but they all derive ultimately from the ability of the chemical to melt ice in the first place. So understanding how different chemicals compare in their ability to melt ice still remains very important. And by way of introduction, I want to first define a couple of terms for you that I think are often conflated with each other and misunderstood to our detriment. And they are ice melting capacity versus ice melting rate. So ice melting capacity is the total amount of ice melting you can get from a chemical at a given temperature. And this value is carved in stone. It is a characteristic constant for any chemical, and you can't change it. It's defined by the basic thermodynamic properties of the chemical. Ice melting rate, on the other hand, is not carved in stone. Ice melting rate is the amount of time that it takes for a chemical to release all of that ice melt that it has available to it. And it depends on a wide variety of factors. The ice melting rate will depend on the size of the deicer particles. It will depend on whether or not there's traffic action. It will depend on how long a period of time that deicer is allowed to work. It will melt ice faster at the beginning and slower as time goes by. It depends on whether the deicer is wet or dry. And if it's wet, on what the pre-wetting agent is. So all of these things will influence how fast the deicer works. And that's an important distinction I want you to keep in mind as we go through our discussion this morning, because what we're going to see is this has important implications for trying to optimize the effectiveness of our deicers and understanding what to expect from them.